Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on spacecrafts. So, in the last session we discussed the satellite segments and we discussed these space segments. One of the very important subsystem of the space segment is the mechanical mainframe, and in mechanical mainframe we discussed the mechanisms, how a mechanism works for unfolding of the antennas or the
solar panels
or the different movements of different instruments. So, that we described. Then we discussed
on board
propulsion system which is there in the satellite for its orbital maneuver or orbit correction. Then we started the electrical mainframes, and in electrical mainframe we discussed the power system. What is the power system and how the satellite powers are generated, primary power source, secondary power source, how the power is regulated. So, in order to continue with the electrical mainframe, we will now consider in this segment that is again the electrical mainframe, and we will consider the subsystem of this is called the telemetry, tracking and command. Then we will discuss the attitude and orbital control system, and then we will discuss in short what are the different types of payloads which are used in the on board the satellite. So, now to start the discussion satellite telemetry, tracking and command. So, basically it is a wireless two-way communication system, and it is present both in the satellite as well as in the earth or ground station. So, you can see this block diagram. This block diagram shows the schematic of the typical TT&C. So, what is the purpose of this TT&C? So, it ensures the satellite, whether the satellite is performing correctly or not, whether any corrections are needed or not, that is only possible when we have this system in the satellite, that is TT&C. So, in general the satellite gets the data of its all the whether it is positions or whether it is the temperature of various subsystems, what is the power output, all this input it gets to various onboard sensors, and the telemetry subsystem of this what is present in the satellite that sends those data to the earth station. So, you can see this telemetry data is sending to that telemetry receivers in the ground station. Now, based on the telemetry data, the control or the command transmitter sends signals to the spacecraft actuators to ensure that the spacecraft bus and the payload do whatever is specified or whatever is necessary to meet the objectives of the space mission. So, as a part of the spacecraft bus, this TT&C subsystem is needed for all type of satellite, whether it is a communication satellite or a navigational satellite or a remote sensing satellite. This is very essential segment of a satellite system. So, now just quickly we will try to exactly define the what is telemetry, what is tracking and what is the command here. So, telemetry is basically the collection of the information on the health and the status of the entire satellite system and its subsystem, okay, and the transmission of this data to the command segment of the ground. So, this data are sent back to the command segment or that is the this telemetry receiver. Now, what is tracking? So, tracking means to know what is the location of the where is the satellite. So, it is the act of locating and following the satellites to allow the command segment to know where the satellite and where it is going. So, this part only we can know when we have the tracking facility in our ground system, as well as we need a receiver also on the spacecraft. This also requires a ranging system. So, ranging system means to know the distance between two points. So, this is the ranging on the spacecraft and a data collection network on ground that allows the ranging. So, for the ranging we need a network. So, that forms the tracking performance. The next is the control and command. So, the
reception
and the processing of the commands to allow this satellite to perform the specified operation in order to provide the services of interest. So, here also the ground system is required. In fact, in TT&C it is the present, it is now it is a space segment as well as it is a part of the ground segment also. Now, what are the measurements is done by the that is the telemetry operation. So, telemetry means measuring at a distance, from a distance. So, what are the status of the resources? Now, the satellite, the resources like the propellant of the thruster propellant. So, what is that the supply and what is the value right at this moment. So, that stock can be that can be measured and sent back to the ground station. What is the second resource, that is the health and the charging status of the batteries. Whatever the batteries are used, whether they are getting charged or if they are getting the charge, what is their output the voltage. Then the attitude of the satellite. Attitude means the orientation. Right. We will explain it in the next slide, what is exactly what do we mean by attitude. So, this is known, it is the reading from the there are different types of sensors are used, I will come to that in the next slide. So, using those sensors, what is the orientation of the satellite, whether it is in its nominal axis or this axis has rotated. So, these things are called the attitude. So, this is also measured by the this system. Then the mode of operation of each subsystem. As for example, the heaters are used as a active thermal control system. So, the heaters are switched on when it is the temperature goes below the specified temperature. So, the heaters need to be switched on. So, it will be able to tell whether the switch this heater is in which state, whether it is in on state or it is in the off state. Of course, the health of each subsystem. So, each subsystem will have different types of the parameters by which we can know what is its health. So, as for example, the output from the solar panels, what is the voltage, what is the current that can be measured. Then temperature of the sensitive instruments like infrared sensors. So, infrared sensors need to be maintained a very low temperature, whether the temperature has been maintained or the temperature exceeded. So, this thing. So, these are the different measurements which is done by the telemetry subsystem. Now, we mentioned about the attitude. So, what is the attitude of a satellite? So, attitude of the satellite means the way the spacecraft is positioned in three dimensional space. So, the attitude of a satellite refers to the orientation in space, the orbit and the body frame of the reference. So, we will explain what is the orbit reference and what is the body frame reference. So, orbit frame means it is the 3D coordinate axis at every point on the orbit, and what is the body frame? Body frame is the 3D coordinate axis which is rigidly attached to the satellite body. The orientation of the body frame with respect to the orbit frame at every point is given by the satellite's attitude. Naturally, what is the task? The task is to align these two frames. So, let us now try to see through some illustration what is the body frame and what is the that is the orbital frame of reference. Now, you can see this is a satellite. So, you can consider the center of this cuboid as the center of this coordinate system, and you can see here the axes have been defined as yaw axis, then roll axis and the pitch axis. I will explain what each type of this axis means so far as the spacecraft is or satellite is concerned. So, you can see in this figure, so this is the orbit, the Earth, it is orbiting. So, you consider at any point on the orbit and connect any point of the orbit to the center of the satellite. So, this axis is called the yaw axis. Now, again so the yaw axis points the direction of the center to the Earth. So, this axis is defined yaw axis, then the next is the roll axis. So, roll axis will be on the plane of the orbit. So, you can just consider the plane of the orbit. So, then plane of the orbit will be defined by the yaw axis and the roll axis. Both the axes are on the orbital plane. So, obviously, the roll axis and the yaw axis are perpendicular to each other, and the roll axis its direction is towards the direction of the velocity of the satellite. So, the direction in which the satellite is moving, so that will be the direction of that that is the you can say this is the positive direction of that axis, roll axis, and pitch axis is perpendicular to the two, because third axis has to be the perpendicular. So, you can see in this figure this is perpendicular to this plane, that is the plane or the orbital plane, which contains the yaw axis as well as the roll axis. So, again this figure shows it more clearly, this is how we define. So, this is the spacecraft and this defines the axis. Now, the question is why this attitude and the orbit of a satellite change. So, there are a number of forces, as already I mentioned when we are discussing about the satellite orbits. So, whenever a satellite is there in the orbit, a number of forces acts on it, and which are called the perturbation or the disturbance that creates a disturbance shocks, which can alter the attitude as well as the altitude of the spacecraft. So, these are the some examples, just already we know, that is the atmospheric drag, then the gravitational fields of the sun and the moon, then solar radiation pressure, then meteorite impacts. So, these impacts also can generate some torques and it can deorbit the satellite. Now, why the attitude control is needed? So, the reason that we need the attitude control, because the spacecraft generally it is needed to have very high gain antenna. High gain antenna means where this antenna, the beam width or the beam is very pointed beam. So, that I can have a very reliable communication, or in remote sensing we can say that I can have a very good resolution. So, this is needed if it is a very high gain antenna. So, it is needed that antenna should accurately point to the earth for communications. If slightest the perturbation will the line of sight will it will be broken, and in that case that communication no communication will be possible to do if the antenna is not properly aligned to the ground stations. Then there are used the onboard cameras and scientific instruments which needs to point to earth and other celestial bodies. This solar cells, this arrays also that they need the sun tracking for maximum spacecraft power. So, that also should be aligned to the maximum the solar flux. So, the heating and the cooling effects of the sunlight and shadow may be used intelligently for the thermal control. So, these are different reasons for which you need the orientation of the satellite should be fixed. It should not move or it should not get perturbed. So, this is called the platform stability. So, for various purposes we need the platform stability. So, now as already we said that satellites attitude or orientation and the orbit control are controlled by a system. This is consists of different types of sensors. So, sensors, why the sensors are needed? Using those sensors you will be able to know that is what is the current where it is. So, the sensors measures its orientation with respect to some known locations, or this where some objects whose positions are known. Okay. Then actuated. So, whenever I know that yes there is some this orientation is changed. So, when I need that because I want to correct that one. So, that time the actuators are used. Then the software is used, it has to be controlled. So, it has to be so various the control operation need to be operated by using proper the software. So, the attitude and orbit control system it provides generally 3 axis stabilized earth positioning attitude control during all mission modes. Of course, there is also a spin stabilized satellite, we will not discuss it here. Spin stabilized satellite. These were used in the first generation of the satellites, they used to use the spin stabilization. We will not discuss that, but here we will discuss the 3 axis stabilized. It means that both the 3 axes yaw, roll and pitch, these axes are stabilized, and it measures and corrects the spacecraft velocity and orbital position. So, attitude and orbital, this is also one of the functions. First is the attitude control, and next is the control the velocity as well as the orbital position. So, the attitude control process involves measuring the attitudes of the satellite by sensors, then comparing the results of these measurements with the required values. So, whenever you have the readings of the sensors, so you know what is the axis, and then the nominal axis positions are known. So, this way comparing these two will give the what is the error and what should be the input to the actuators. So, once you know these two, the corrections which need to be made to reduce the errors, it can be calculated. Now, introducing these corrections by operating the appropriate torque units. Now, you can convert it to what is the torque, what is the force needed. So, that can be calculated based on what are the errors. So, these algorithms to command the actuators based on the first the sensors measurements of the current attitude and the specification of the desert attitude. Now, what are the different types of sensors used? So, what are the sensors? Basically, these sensors measure the orientation of the satellite axes with respect to external references. So, those external references are fixed, they are known, they are so such as the earth, then sun or the stars. So, their essential characteristics is the accuracy. So, it depends not only on the procedure used, but also on the alignment errors of the detectors with respect to the body of the satellite, because those whatever the sensors they are mounted on the spacecraft. But suppose if that alignment there is some alignment error or those there is some issue with this alignment accuracy degrades. So, that time the accuracy will go down, because this what if how the sensors are aligned to spacecraft, that will decide this accuracy of the sensors. So, many sensors they generate output that reflects that the rate of change of the attitude. So, how the attitude is changing, so that can be known from the generated output from the sensors. So, this first sensor which are used, that is called a horizon sensor or earth sensor, then there is sun sensor, then star tracker, then gyroscopes and radio frequency sensor. So, these are commonly used sensors to calculate the attitude of this orbiting spacecraft. So, we will just quickly try to define what is or to know about the earth sensor. So, basically the earth is surrounded by its atmosphere. So, whatever the atmosphere, whatever the the particles are there, it is like a it is a radiator, black body radiator. So, this from the spacecraft if there is a sensor, so it looks to the center as if as a spherical black body at the temperature of 255 degree Kelvin, and this radiation is measured in a particular wavelength. So, this is measured in the infrared
absorption
band of carbon dioxide. So, this is the 14 to 16 micrometer. So, so using different type of different sensors more than maybe 3 or 4. So, the center of the earth can be, so center of the earth it can be located, that is the direction. So, center of the earth means this yaw axis will be can be known from using this earth sensor, but it is not only one, but more than one are used. So, you can achieve an accuracy of 0.05 degree by using the earth sensors. Then sun sensors. So, sun sensors they use the photovoltaic elements, so which produce the currents when illuminated by the sun. So, they measure 1 or 2 angles between their mounting base and the incident sunlight. So, incident sunlight that is fixed, that flux direction is fixed. So, in that case whenever we get a number of measurements, so we can calculate whether there is any deviation there or not with the spacecraft of the spacecraft. Then there are the star sensors. The location of the stars are also fixed for whatever the time scale we consider over that thing, the stars are fixed in the sky. So, image of the given portion of the sky that provides a map of these stars whose relative positions are detected and compared with the reference map. Then gyroscopes is a device, it is used for measuring or maintaining the orientation of the angular velocity. Then radio frequency sensors are also used. So, these depend on the measurement of the characteristics of the radio waves transmitted to the satellite by ground radio beacons. So, from there you can measure the angle between the antenna axis on board of the satellite and the desert direction of the beacon. So, this thing can be measured. There are tracking, that is RF tracking techniques available from where you can calculate what is the from the beacon direction and actual this satellite antenna. So, what is that the mismatch. So, from there also this what is the attitude correction and what is the change in the attitude that can be determined. Okay. Now, we will discuss the actuators. Actuators means where this signals are, that is that errors are put, and then it gives a movement. It can be torque or it can be a translation. So, modification of the attitude is generally obtained by generating a torque which, taking account of the dynamics of the particular satellite, causes an angular acceleration or velocity about an axis. So, the attitude control actuators therefore have the purpose of generating torques. So, what are the various types? So, it can be thrusters, then reaction or the momentum wheels, then control movement gyros, solar sails where the radiation pressure is used control to create the torque. Then there is gravity gradient stabilization, then magnetic torquers. So, these are the different types. I am not going the details to each type, but these are the types of actuators which are generally used. Now, just I will quickly mention about what is the 3-axis stabilization. So, the term 3-axis stabilization, it denotes an attitude, the control system in which the body of the satellite maintains a fixed orientation with respect to the local coordinate system. Since the body of the satellite maintains a fixed orientation with respect to the earth, mounting of large antennas is facilitated. So, here the direction and all these things can be specifically it can be aligned according. Then another, this is the unfolding of the solar panels. So, solar panels is generally it is aligned with the pitch axis, and it rotate about this pitch axis in order to follow the apparent daily movement of the sun about the satellite. Now, another very important, that is the electrical, that is the subsystem, it is the satellite payload. In fact, all the functions of the satellite or the purpose of the satellite is fulfilled by the satellite payload. Okay. So, satellite payload is the module which is carried by the satellites, and it has the ability to perform the certain functionalities. Already we discussed about those. So, satellite consists of the payload and the bus. Bus means the structure of the satellite. So, satellite bus is used to carry the subsystems and the payloads, whereas the payload is developed to perform specific functions such as it can be communication, it can be the imaging of your earth surface or the navigation or scientific missions while in orbit. So, satellite payload include the equipment such as transponders or the repeaters, these are for the communication, then these antennas, then it can be a spectrometer, then it can be camera, it can be even radar, altimeter, so many payloads, different types of payloads are there. Earth and remote sensing application use cameras, radars and other sensing equipment for collecting the relevant data. So, to enable the delivery of the satellite communication services, so the payload includes antennas. This is a very essential component. It has to have an antenna, then it to have a receivers, then the transmitters. Okay. So, these are the very important subsystems of any type of payload, and payload vary in sizes and its functionalities, then its capabilities. It's always it is payload to payload, it differs. So, already these were defined. So, different type of the payloads are the communication payload, the navigation payload, remote sensing payload. And in communication payloads, that is the satellite or the space shuttle or space station is the focal point for the receipt and the transmission of radio signals to a network of earth station. So, because of their high altitude or elevation, satellites can view large surfaces of the direct line of sight. So, for the geostationary orbit, it can cover one satellite can cover at least 1/3 of the earth's surface. So, frequency bands which are used. So, these are the frequency band 6 and 4 gigahertz, then this is this is called the Q band, it can be even Ka band, and whenever the bandwidth requirement or for most of the systems are the 500 megahertz for each direction, and for large bandwidth are expected when the frequencies are above 20 gigahertz. And all the frequencies allocated, whatever the frequency, it has to be regulated by the International Telecommunication Unit called the ITU. So, the communication payload, it contains the communication transponders, these antennas and associated involved directly in the receipt and the transmission of radio signals from the earth to from the satellite to the earth station network. So, most transponders are operational used in the present time are the transparent or it is also called the bent pipe transponder. So, it is means that a satellite gets an uplink signal, then it does the frequency translation, amplifies it and sends it back to the earth station. So, this is called a bent pipe transponders. There are the other type, this is called the regenerative transponder. So, in these degenerative type of transponders, the signal basically this uplink signal it is processed, means the signal to noise ratio is improved and then only after doing an onboard processing it is sent back to the. Okay. So, this shows this block diagram of a regenerative transponder. Now, the navigational payload. So, navigational payload here using the a navigational payload, you know what is the position and time anywhere on the earth. Okay. So, there are different a constellation of satellites are used to do that, and this is basically it is radio signals are used for the ranging and a number of satellites are used to carry out the navigational activities. So, at least 4 satellites are needed to know that is unambiguously the position of a receiver. So, these are the different all of you know these are the different types of the satellite navigation system available, that is global positioning system, then Russian GLONASS, then European Galileo, then Baidu that is by China, then our Indian we are having this IRNSS or it is also called the NAVIC. And remote sensing satellites, so there are 2 types of remote sensing satellites or the payloads are there are 2 types, that is the micro payloads contain the radiometer sounders and the radars, the scattorometer, synthetic aperture radar, altimeter, precipitation radar, etc. Optical payloads, this can be in the visible, near infrared or short wave infrared systems. So, the optical imaging system can be classified according to their spectral band used. So, this can be monospectral or panchromatic like single wavelength or black and white grayscale image system. It can have a multispectral, that is several spectral bands, or it can be superspectral, tens of spectral bands, hyperspectral when hundreds of the spectral bands are used. So, just we have concluded today's session. So, I just described this electrical subsystem, mainly the TT&C, then attitude and orbit control system and the payload. So, we will go to in the next session we will again start with a different type of the electrical subsystem. Thank you very much.